So, in an article that appeared on Inside Climate News, to counter global warming, focus far more on methane, a new study recommends. Well, duh. How long have those of us who study uh, the science behind climate change, have been warning folks of the dangers of methane? You know, whether it's myself, Natalia Shakova, Igor Semiletov, etc. et al. We've been talking about this. We've just been being ignored. The IPCC ignores methane, barely gives it a paragraph in the reports. Scientists at Stanford have concluded that the EPA has radically undervalued the climate impact of methane, a short-lived climate pollutant, by focusing on a 100-year metric for quantifying global warming. Well, let's talk about this right here. A short-lived pollutant. Well, that's a load of crap. Yeah, methane quickly oxidizes into CO2. And we know how long CO2 lasts about. So the warming effect continues. This sounds like EPA is just doing poor science here, really. But we know what? That the EPA does provide information to the IPCC. So this is just under the category of like gross incompetence. Oh, flames from a flaring pit near a well in the Bakken oil field. Yeah, right. The EPA is drastically undervaluing the potential or the potency of methane as a greenhouse gas when the agency compares methane's climate impact to that of CO2. The EPA's climate accounting for methane is arbitrary and unjustified and 3 times too low to meet the goals set in the Paris Climate Agreement. And this is a report published in the journal Environmental Research Letters. Okay. So the report proposes a new method of accounting that places greater emphasis on the potential for cuts in methane and other short-lived greenhouse gases to help limit warming to 1.5 degrees C above pre-industrial levels. Newsflash, we're already at 1.5, if not beyond it. If you want to keep the world from passing 1.5 degrees C threshold, you want to pay more attention to methane than we have so far, said Rob Jackson, an Earth System Science professor at Stanford University, co-author of this particular study. Methane is the second leading contributor to climate change after CO2, and is a far more potent greenhouse gas. Unlike CO2, which can remain in the atmosphere for centuries, methane is a short-lived climate pollutant that stays in the atmosphere for approximately 12 years and then oxidizes, probably it's actually a little longer than that, but the point is it still oxidizes the CO2, so the effects are still there. The vastly different atmospheric lifetimes of methane and CO2 make comparing the climate impact of the two gases difficult. Well, not really, because we keep putting methane into the atmosphere. Be it the continuing thawing of the permafrost, increasing biogenic activities, thermogenic activity. So even though some of the methane oxidizes CO2, it's basically replenished. And as the warming continues, the replenishment and increase in levels will continue. The EPA, following guidance by the United Nations Framework Convention on Climate Change, UNFCCC, quantifies how equal amounts of different climate pollutants like CO2, methane, nitrous oxide contribute to warming the planet over a 100-year period. Comparison allows government agencies and the private sector to weigh, quote unquote, the relative impacts of different greenhouse gases and then determine how much emphasis to place on reducing their emissions. However, the use of the 100-year yardstick results in a greater emphasis on pollutants such as CO2 that remain in the atmosphere for a relatively long time and downplays the contribution of short-lived pollutants like methane, even though they do far more on a metric ton for metric ton basis to form the atmosphere in the short term. Okay, let's highlight that. The use of a 100-year yardstick results in greater emphasis on pollutants like carbon dioxide that remain in the atmosphere for a relatively long time, downplays the contribution of short-lived pollutants like methane, even though they do far more on a metric ton for metric ton basis to warm the atmosphere in the short term. This is an incredibly important statement. And we know that the IPCC does the same sort of stuff, and this is why their projections are always underestimation, and plus the fact they keep going with linear models instead of exponential model. But this is part of the reason why the projections of how much increase temperature, how much temperature increase will occur later on is always low, as well as why the estimation of how much warming that has taken place is also always lower than what it really is. So this is probably the crux of the problem right here. Sam Abernethy, which is a Stanford doctoral student, lead author of the study, he said became interested in the global warming potential of methane after looking into why the U.S. and other countries use the 100-year time frame. And he found that the period of 100 years was arbitrary and unjustified choice adopted by the Kyoto Protocol. Just like the IPCC keeps moving the baseline, 1750, 1850, 1880s, that's also, to me, is unjustified. 1750 is not arbitrary. That's when the Industrial Revolution began, albeit small, in a small way, but it began there. You know, when you change your baselines around, you're changing your methodology, and actually makes comparisons problematic. Let's put it that way. The 100-year measure was selected for the Kyoto Agreement because it was the middle ground between two other possible time frames, 20 years and 500 years, provided in earlier reports by the IPCC. Why 500 years? That's, it's difficult to project that far out. I was confused at how something so arbitrary could be underpinning so much of climate policy and how we think about different greenhouse gases. Yeah, that's a very valid thought process there. Over a 100-year period, methane is 28 times more potent than CO2 as a greenhouse gas. However, over a 20-year period, a yardstick of climate science that previously suggested would be more appropriate time frame, methane is 81 times more potent than CO2. It's a huge swing in how much we value methane and therefore how many of our resources go towards mitigating it. But using either time frame remains largely arbitrary. To determine a quote-unquote justified time frame, the Stanford researchers took the Paris climate goal of limiting warming to 1.5 degrees C as a starting point and calculated the most appropriate time frame to meet that goal. Based on climate models using scenarios where global warming is limited to 1.5 degrees. Excuse me while I have a snort and a chuckle over that one. They determined the planet would reach 1.5 degrees of warming above pre-industrial levels in approximately 24 years. What? That's an overshoot. Well, as I said, there's some indications we're already at 1.6. Oh, that's right. The different values are depending on the different baselines. Even if you were to accept the 1.2, that's the official, value IPCC has put out. Look, to say we're going to get to 1.5 in another 24 years and not a hell of a lot sooner, Please share whatever foliage you are smoking. We could all use a hit. If that's the case and you're using 100-year frame for methane, then you're not going to put enough value on reducing methane emissions compared to other greenhouse gases. Over 24-year time period, methane is 75 times more potent than CO2. That is 3 times higher than 25, the current value the EPA uses for methane. Backlund says CO2 remains the most important greenhouse gas, but he added additional attention must be paid to methane if we want to limit to 1.5 degrees C. Again, you know my thoughts about that value. But here's the other thing. What's going on with the permafrost? What's going on with the shelf? We know that methane is rapidly being released, and the amounts being released is rapidly increasing. And quite honestly, we've already locked that in, what's going to happen. So there's a lag effect. So what the warming is now today, the levels of today is going to be felt down the line, 10, 15 years down the line. So that's the other thing. They're talking about 24, 25 years, and where we have a lag effect of basically 10 to 15 years from current levels to what the temperature will be. So there's a complete total mismatch going on here. So it goes on to talk about how they're going back and forth, trying to justify the methodology, et cetera, et cetera. How, we got to keep reducing CO2. Okay, yeah, it's valid. You want to reduce CO2, but you do have to mitigate methane. In the run-up to Glasgow, many environmentalists and officials in the Biden administration argued that a focus on reducing methane emissions would have a much greater impact in the short term than a focus on carbon, given how much more potent methane is, how much longer carbon stays in the atmosphere as carbon dioxide. Don't forget, methane contains carbon. Focusing on methane, they said, would give governments the ability to slow global warming in the near term while buying additional time to tackle long-term warming driven by CO2. Oh, ocean heat content, anyone? 240 zettajoules waiting to diffuse back to the atmosphere? Good luck. So there you have it. Little late coming to the table, or coming to the party, whatever the saying is. Oh, we got to focus more on methane. There's been a whole bunch of us been warning about this for how many years? How many decades? Yeah. There's a saying, better late than never. Well, it probably is too late, no matter. We'll talk soon. Thank you for your time. Hello, folks. This is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.